You've probably never once in your entire life thought of yourself as the last survivor of anything, but in a very literal biological sense, that's exactly what you are. At least 8 other distinct species of human once existed on this planet at the same time as us, or in the long stretch of time right before us. Neanderthals spread across Europe and Western Asia, stocky and cold adapted, surviving Ice Age winters that would kill most people alive today within days. Denisovans, an entire branch of humanity known to science, mostly from a handful of bone fragments and a single tooth found in one Siberian cave, discovered almost by accident. Homo erectus, who survived for close to 2 million years. A run so long it dwarfs how long our own species has existed by a wide, almost embarrassing margin. Homo floresiensis, a small-bodied species barely a meter tall, nicknamed the Hobbit, isolated for tens of thousands of years on a single island in Indonesia. Every single one of them is gone now, permanently, without exception. Only one human species is left standing on the entire planet to even ask the question of why. The easy story, the one that shows up constantly in documentaries and casual conversation alike, is a story about conquest. Modern humans arrived on the scene, smarter, more cunning, better armed with sharper tools and better weapons, and simply wiped out whatever competition happened to already be living there first. It's a clean, satisfying narrative, the kind that makes for good television. That story turns out to be mostly wrong, or at least seriously incomplete, and the proof came from somewhere almost nobody expected it to. Not a battlefield, not a weapon, bone fragments and ancient degraded DNA, painstakingly recovered from fossils. The geneticist Svante Pääbo spent decades painstakingly developing the technology needed to sequence genetic material out of fossils tens of thousands of years old, degraded and contaminated after all that time, work precise enough and important enough that it eventually won him the Nobel Prize in 2022. In 2010, his team completed something remarkable, the first full genome sequence ever pulled from Neanderthal bones. What it revealed didn't fit the tidy extinction story at all. Roughly 2 to 4% of the DNA carried by most people outside Africa today traces directly back to Neanderthals, present in nearly every non-African person walking around right now, whether they know it or not. Pääbo's team later found evidence of an entirely unknown human species too, the Denisovans, identified from almost nothing more than a single finger bone and a tooth in a Siberian cave, and confirmed that modern humans interbred with them as well, in some populations leaving an even larger genetic trace than the Neanderthal one. Whatever happened between these different human species, over however many centuries of overlap and contact, it wasn't simply one side killing the other until absolutely nothing remained. In some very real, measurable genetic sense, written directly into the DNA of billions of living people today, Neanderthals and Denisovans never actually vanished completely. They partly became us instead. So if it wasn't pure conquest, what actually tipped the balance so heavily toward one species surviving? Part of the answer seems to come down to something much less dramatic than warfare: connection. Archaeologists digging at a site called Mezhirich in what's now Ukraine found jewelry roughly 18,000 years old made from Baltic amber and Black Sea shells, sourced from hundreds of miles away in 2 completely different directions. Other early Homo Sapiens sites scattered across Europe regularly turn up seashells from coastlines the people actually living there had almost certainly never personally visited in their entire lives. None of that happens by accident, and none of it happens without real, sustained effort. It means separate bands of Homo sapiens, spread out across enormous distances that would take weeks to cross on foot, were somehow staying in contact anyway, trading, maintaining working relationships with people they might only actually see once every few years. Neanderthal sites, excavated just as carefully and just as extensively, show essentially none of this pattern. Their stone tools were made almost entirely from raw material found within about an hour's walk of wherever the tool was actually used, over and over again, site after site, with only the rarest exception. Homo sapiens, by contrast, built something closer to an actual web. A resilient, far-reaching network of separate but connected, mutually supporting groups stretching across a continent. Neanderthals, as far as the physical evidence shows, largely didn't build anything like it. A network that wide matters enormously in practice. When one group has a genuinely terrible year, a drought, a disease outbreak, a failed hunting season that leaves everyone hungry through winter. Distant allies further down that same trade network can share food, tools, knowledge, or eventually even people to help the struggling group recover before it collapses entirely. An isolated group facing that exact same disaster with no wider network to lean on simply has no equivalent backup plan. Over enough thousands of years and enough repeated bad seasons that one structural difference compounds into something decisive. The paleoanthropologist Chris Stringer, who has spent roughly 5 decades of his career studying exactly this question at the Natural History Museum in London, argues the full picture needs at least one more piece layered on top of genetics and trade: timing. For long stretches of time before modern humans ever set foot in Europe, the climate itself was swinging wildly and repeatedly, brutally cold for a century or more, then nearly as mild as today the next, sometimes flipping from one extreme to the other in less than a single decade, faster than any culture could easily plan around. Neanderthal populations had to weather all of that instability essentially alone, spread thin across the landscape in smaller, more isolated groups, with a narrower range of adaptive strategies, and crucially, none of that wider trade network to fall back on when local conditions turned hostile. Then, on top of an already destabilized population, anatomically modern humans arrived and started competing directly for the exact same shrinking resources at close to the worst possible moment for anyone already struggling. Stringer's research suggests it likely wasn't any single dramatic knockout blow, no decisive battle or sudden catastrophe. It was climate pressure first, sustained and repeated over centuries, then direct competition for food and territory second, both landing on a population that was already stretched thinner than it could comfortably absorb. Put every piece together, the genetics, the trade networks, the climate timing, and the picture that emerges looks a lot less like a war story and a lot more like an uneven slow-motion contest of pure resilience, decided gradually across thousands of years, rather than in any single dramatic moment anyone could point to and call decisive. Homo sapiens weren't uniquely brilliant compared to every other human species that ever existed, and the evidence doesn't support uniquely violent either, despite how often that version gets told. What they apparently had more consistently and more reliably than the others was reach. The practical ability to stay connected across real distance, to keep trading, keep sharing, keep a lifeline open to people who weren't standing right next to them the moment things went wrong locally. That's not a flashy advantage. It doesn't make for a dramatic documentary reenactment. But stretched out patiently over tens of thousands of years and repeated environmental crises, one bad season compounding into the next, it was apparently enough, all on its own, to be the deciding factor between a species that continued and several that quietly didn't. You're not simply descended from the sole winners of some ancient one-sided conflict, the last ones standing after everyone else was wiped out. You're carrying actual pieces of the ones who supposedly lost embedded directly inside your own genome, reading this sentence right now, whether you ever knew it before today or not. Extinction, it turns out, was never quite as total or as final as that single blunt word usually suggests.